Thank you for tuning in for today's event. We're going to wait just a couple of minutes before kicking things off to allow everyone who's trying to participate to join in. Hello, this is Judy Murray, your moderator for today's webcast, Leveraging Advanced Networks for Superior Remote Operations, presented by Rajant Corporation and Winn-Marion Companies. With the help of our presenters, Al Rivero, Vice President of Global Energy at Rajant, and Scott Adams, Network Expert at Winn-Marion, we're going to learn how to make the most of remote operations to improve the bottom line. Before I hand things over to Al and Scott, I'd like to tell you a little about Rajant and Winn-Marion. Rajant was founded in 2001 and is headquartered in Pennsylvania. It is an exclusive provider of peer-to-peer private kinetic mesh networks consisting of breadcrumb wireless nodes powered by its patented InstaMesh networking software. Rajant has hundreds of installations to its credit for the military and across industry, including mining, oil and gas, agriculture, transportation, shipping, petrochemical, manufacturing, and for municipalities and federal and state governments. Combined, this constitutes more than 40,000 network nodes operating in a variety of private networks. The Winn-Marion companies trace their roots to 1972 and a Georgia Tech chemical engineer with a vision of solving problems using emerging technology and the conviction that there is always a better way to deliver value. Over the past 48 years, the company has branched out from its base in Denver, adding 11 offices throughout the Rocky Mountain region and expanding into Texas, Pennsylvania, Ohio, and West Virginia. Today, more than 200 Winn-Marion employees are working to help companies in the industrial and semiconductor process markets leverage leading-edge technologies to streamline networks to extract the best value. I know you're ready for Al and Scott to begin, so I just have a couple of things to tell you about participating in today's webinar. First, you can submit questions at any time by clicking on the Ask a Question area, typing your question, and clicking the Submit button. After the presentation, Al and Scott will answer as many questions as time allows. Any question that cannot be addressed within the time constraints of the webinar will be answered by email. For your convenience, the presentation will be available on demand within 24 hours of today's event, and a reminder email message will be sent to all registrants with a link to the archive. The webinar also will be accessible from the homepage at upstreamonline.com. And now just a couple of housekeeping notes. If you're running pop-up blocking software, please disable it to view the webcast. And we also recommend that you close all other applications for the best system performance. Now, over to you, Al.
One of the things that we'd like to discuss is the different architectures that are currently in place today. So thank you, Judy, for turning it over, and hopefully it's informative to everybody that's listening. Traditionally, in oil fields, there's either they don't do anything today to monitor, and if you look at some of the stranded wells and some of the orphan wells that are currently in operation today, there's a variety of reasons why companies have not implemented some of the monitoring technology or some of the networks to get to them. One of the things we're going to try and discuss, and hopefully you get some appreciation for the networks and the infrastructures that are out there today, is how to connect all your field sites together. And currently today, there's a variety of networks that are in use. Point-to-point, which is the traditional infrastructure that's been used out in the field directly. There's a bunch of companies that do that traditionally. It's a high speed, high capacity, long distance. It's fairly reliable. It's usually used on fixed infrastructure, and it works pretty well. Point to multi-point, kind of the same thing. It provides coverage to disjointed areas with a little less infrastructure. It aggregates many remote sites, so you have a central tower, and it goes out and captures data or from peers that are out in the field surrounding the sites. Those have historically been the way that information is gathered from remote operations. And then what we're going to spend a lot of time talking is mesh and our kinetic mesh infrastructure, which is each breadcrumb in the network forms a living network. And we're going to go into a little bit about that. And it's a different way of looking at how you're going to automate your field and how you're going to bring data back. And with our partner, Winn-Marion and Scott, we're going to give you some examples of architectures and talk about the best way to do it. The mesh technology is very unique in our world because we don't require a controller, and we'll go into a little bit about that. It's easy to deploy, and it works well with machine-to-machine learning and mobility. So we'll talk a little bit about that. So you can really implement the IoT 4.0 infrastructure that you're looking at. Kinetic mesh communication, I'm going to simplify how that works. In the infrastructure, there is no single point of failure. If you look at point-to-point or point-to-multi-point, there's a hub that connects all these sites together. If you lose that hub, then you lose all the sites. In the traditional mesh architecture, there's a controller, and that controller, if it fails, you also lose some of the linkage that enables the communication. In kinetic mesh, there's no single point of failure. All the breadcrumbs are a controller and can have hundreds of peers connecting to each radio, and the radio determines, using a costing algorithm, which way to communicate, and that transfer is dynamic. And it uses the fastest path to communicate with all the other nodes and to deliver the data accurately and reliably when you get to those points. When you're looking at the kinetic mesh infrastructure, so we have a patented network architecture. It's all built around the InstaMesh protocol. So each breadcrumb runs a proprietary InstaMesh protocol, and we really don't care what frequency you're using to manage that infrastructure. It can be 5, 4, 9, 2, 4, 900. It can be a licensed frequent. We're very flexible on frequency usage. When it comes to that, we have some standard products that have baseline frequencies, but we can also do other frequencies if that's required. We can provide a very unique wireless infrastructure, very unique security, quality of service, and automatic connection adaptation to each of the breadcrumbs when they move. One of the things, we are a high bandwidth, low latency connection. So when you're out in the field, you can do a lot of things that historically you haven't been able to do. And we'll get into that here in a little bit. What I'm going to kind of break apart for you is kind of the difference between traditional mesh and kinetic mesh. In traditional mesh, you're typically relying on a single frequency, and if interference is caused, then you have data interruption or latency. In a traditional mesh, you require a controller. If that controller fails, it disrupts you and disrupts the messaging. You have the lack of ability to provide the infrastructure to mobile workers. So in a typical field that we deploy, a lot of times we'll have fixed infrastructure, which is the oil wells and the production facilities, gas plants, and those things on telemetry VLANs, and then we'll have mobile workers that can do everything from point to point for push-to-talk technology. They can use their iPhones or Android phones to check emails, communicate with the home office, and we'll talk a little bit about how that architecture works. In the kinetic mesh world, what we do is each breadcrumb is basically 4 radios. In this particular example, 224, 258 radios. So we are actually a full duplex where we're transmitting and receiving at the same time, improving the bandwidth. The multi-radio mesh routes based on a costing algorithm and also works to avoid any kind of interference automatically. So if you have 2.4 interference, it'll transmit on 5.8. If you have 5.8 interference, it'll transmit at the other frequency, and it'll work around the areas where you have issues. The other thing, in a traditional mesh, if you add more nodes, a lot of times you add more latency. In our infrastructure, the more nodes you add, the more resilient the network becomes, and the more reliable it becomes. You do lose some latency when you get to a certain number of nodes, but you can have hundreds to thousands of nodes in a network, and they'll work simultaneously without degradation of data. And like I said earlier, it'll support VoIP, data, multicast video, a lot of things. So we do a lot of things, not just oil and gas upstream operations, but we also work in other areas that enable that type of broadcasting to take place. The other thing that we support is when an outage occurs in a traditional mesh, you lose that segment. You lose all the nodes in that area. And as a result, you have a communication shutdown for that whole area. In the kinetic mesh world, if you lose a node, only that node is impacted, but the system automatically reroutes the traffic to other nodes around it so that you don't have that failure take place. So all the nodes surrounding it pick up the slack as long as they have communication paths and enable that communication to continue and flow seamlessly until you go back and put that node back in place. That transition usually takes 1 to 2 milliseconds, and it's very seamless to the operator or the individual involved in that transaction. A lot of times our customers don't even know that that's taken place. I'm going to give you this animation because it's a really good animation to show just how kinetic mesh works, whether you're in a fixed facility or in a mobile environment, whether you have plants, trains, forklifts. The environment works autonomously throughout the entire infrastructure, creating nodes that communicate with each other. When you're in an oil field operation or in a plant environment, whether it's a gas plant, stripping plant, or you're doing injection production wells, all those nodes tie together to make that bridge happen, and it becomes a fairly seamless flat network. As you're migrating through, you yourself can become a tower by wearing a vest with a breadcrumb on it, or you can mount one on a truck, and that actually enables the communication to go further and reach more. As the network grows, the resiliency grows, and the paths to communicate are enhanced. Same thing if you're working in a crowded environment or city, your plant could be, or your operation, it doesn't really change anything. The breadcrumbs will continue to talk to each other. So a lot of operations in the production world or in the gathering can be within a city environment. If you're out in Midland, Texas, or Dubai, where you have wells that are scattered throughout municipalities, or you have a field that's fairly remote and you have nothing around it, the infrastructure works pretty seamlessly to allow all those assets to work together and provide that living network. What we want to do with the kinetic mesh network is provide you the infrastructure so you can do work today, but also future-proof your investment so you can do things that maybe you had not envisioned today. A lot of infrastructure is deployed traditionally where the client will go and deploy just a standard network. And if they want to do voice, they'll deploy a separate network. If they want to do email, they'll deploy another network. In our infrastructure, you can do it all in one network, one investment, and make that happen. With that, I will turn it over to our system integration partner, Scott, and he will give you some examples of some of the things we're doing and some of the architectures that are being deployed. Scott?
Yeah, good morning, Al, and the group. First off, before I start, I'd like to thank everybody for joining us. And just a quick message for anybody that doesn't know myself or Al. We are kind of similar to Penn and Teller. One of us is big and loud, and the other one is talented. So I'd like to thank Al for his contributions. Okay, with that, we'll go ahead and get started on our section here. This is this first slide. We're discussing kind of the end devices that are really common in the oil field. On the left picture here, you see a bunch of RTU total flows doing basic measurement. This is something that has been done for years and years. In this setup, we're back to the point to multi-point Al discussed earlier. There's very little communications between devices. If anything breaks along the way, you can lose a ton of data. This type of setup is, it's an old style and it has worked for years, but it's definitely not ideal for the world we live in today. Especially trying to keep operators out of hazardous areas. So we're going to go ahead and touch on the next slide, which kind of brings us a little bit more to where we are today. On this top slide, you'll see kind of what we just discussed. You got a measurement device for every stream. It's costly. You got to put a radio in every single one of those, an antenna. You're adding a bunch of radio noise for every single one of those, and in some cases, you can actually cause your own radios not to work just by having too many radios in such a tight area. What we moved to after that is a little bit of a more modular setup. Can't necessarily tell in the picture very well, but you see kind of one RTU, and you'll see a bunch of multivariables, things that we can bring in. So we're bringing multiple devices into one, and from there we can cut down on our communications, cut down on the need for equipment. So this saves us money, but again, it's not really ideal. They're still on an island. by themselves, and if anything happens to the communications, they all could go out, and in some cases it could take hours or days to get back out to those sites and get everything operating again. What we've labeled as today here towards the center of the screen is our modular design. We put a modular controller inside that allows us a bunch of applications, things that can grow as we grow. So you don't necessarily have the static issues anymore. You bring in a new well, you just turn on an application. But the strength to what we actually did here is the modular controller with the kinetic mesh network and the remote I/O unit. In a lot of cases, we've seen like a 24 well pad that's got plunger and AGA, API applications. In old design, kind of your yesterday design could be 11 total flows that you would need to do that. And again, that's a static setup. So, you'd have trouble modifying that after the fact. With our new design, we could put one of our modular setups out there and we can handle all of that equipment and have growth. So we've also got, in our third case there, really similar application. We'd have 5 Rock 800s, 8 Rock 107s to run 32 wells. Same thing, we've got, in this case, one modular controller and our kinetic mesh network and our remote I/O, and we're able to utilize that and continue to build. It allows us the connections that we need to grow that network without worry that we're going to run out of, we're going to be in a spot where we can't get radio communications, anything like that, because with our kinetic mesh, as long as we're able to see at least one other node, we've got a steady connection. And if one of those does go down, it just instantly passes to another route. Okay, so this is a diagram more common to what we would see, and this is an illustration of how these devices would end up talking back to a controller. Then we can get to our backhaul. This is sort of the design shows going back to one controller, but the benefit of the mesh is it could talk to any of those devices. So say we've got a flare stack that's pretty far out. It could be pretty cost prohibitive to have to trench and do one calls and run wire out there just to grab a communications, whether your flare's on or off. And then that can be a very expensive mistake if your flare's not operating. We could have huge fines, and then just the safety of it as well. So with our kinetic mesh, our flare, we simply need to put a little solar panel and a radio out there, and it could talk back to our production tanks, our compressors, whatever else is out there, saving us a ton of money, like I said, from the infrastructure itself, having to put it in, and also from environmental fines possibly. The other thing I'd like to point out on here is from a user perspective and from a safety perspective, that with our mesh network, we now have all this stuff communicating between itself. Traditionally you'd have to pull up on pad, get out, get your Ethernet cable, get some type of a cable, hook into those devices. Like I said, besides the fact you're on, out on a pad that could be hazardous, H2S and other chemicals and gases that are there, you just have to go out there. There's no way around going out there. And with the Rajant mesh network, we are able to see our system by either having a node in our truck, or there's also access to Wi-Fi. So we are able to get our laptop right on Wi-Fi. Saves us from having to go out and connect. Saves us from even having to be on the pad. In this setup, this shows sort of one pad, but the truth is all of our pads could be linked. All of our facilities can be linked. You may be 2 counties over and hear that something's not working right, or you get somebody driving by saying you've got some issues with your site, you can just get right into that mesh network, hop over the network, and actually see. In some cases, if you've got cameras, things like that, you quite literally could see what's going on. And of course, shut in, do what you need to do to safely continue your operations. Okay, so this is some of the savings that we've talked about with our one system solution. I mentioned earlier that there's no need to trench. This could be a 20 to 30% savings over having to actually trench to devices, and then on top of that, it's easily scalable, right? So any new equipment that you put out simply takes a kinetic mesh node, and you are in the system. So it's something that you may not plan to do something now, or you may plan for 4 well sites now, and further on down the road, you determine you want to do 4 more for 8. In the past, you've then got to consider how to get that talking back, or the cost of additional equipment to add new controllers. With this solution, it's something that we can just put in a radio with whatever equipment you've installed, and it's now one system. So to assist with our kind of one system solution, we've got our turnkey skids that we do. This is something where we already have all the equipment tested. We have all the wires checked. Everything in this case is ready for us to drop on your site, and all you need to do is tube in your gas, or your whatever you're putting in, gas, water, oil. You would tube that in, and with our Rajant kinetic mesh, we are again right in the system. Program your PLC or controller that you may need, and what we've seen real world is we've seen a customer that was putting this same equipment. It was taking over a week for them to go out and commission the site. By doing our turnkey skids with the Rajant kinetic mesh, 2 people that had never commissioned these sites before, were not familiar with the facilities that it was going into, were able to go out and in about a day and a half commission it. So they saved 3.5 days from the beginning. And then, having talked with them, we feel like any familiarity with this particular solution, going out a second or third time, we could have had that under a day. So by using this solution, not only is it already ready to go for you, everything's checked, tested, you would save quite a bit of money by 4 days of labor for every site that you were doing this on. And this is another one of our skids, kind of one of our gas injection skids. It's the same thing we were talking about a minute ago. We are able to build these skids ready to go, and because of our partnership with Rajant, we are able to bring them back in. We can have this stuff tested. SCADA can be checked within a day or 2, which is a huge cost savings. And then again, the flexibility of it. So this may be an 8 well, or in this case, the picture is a 6 well. Excuse me. We could turn on another 6 wells in a day or 2 once you're ready for it. We know in the oil field, time is money, and not when you're not flowing, it is a huge cost to you, or huge potential loss anyways. The next slide we have here is our chemical injection skid. Similar to our measurement skids that we have, we've talked with customers, and on most well sites, we found out that it's either the first or second most expensive thing they do is chemical injection. With our one system solution, we are able to put in an intelligent controller that can actually control the well, or the chemical injection of a well, based on flow conditions, And on top of that, we use top of the line parts. So the accuracy is extremely accurate. In the past, we were finding that companies were injecting way too much chemical. We found they were injecting when the well was shut in, and either spilling chemicals, not getting it in the well properly, or in some cases just completely wasting chemical. So with this system, it's a smart system, able to tell if the well is flowing, under what conditions. So we only are injecting what we need when we need it. And again, this is something that is only made possible because of our kinetic mesh. We are able to bring that back in to the rest of the network, so your controller can see it. Any HMIs on site will be able to see this. You can get on Wi-Fi and see this, make changes to your controls that you need, and then of course have it coming into SCADA. It's just something that the older way of doing things was not possible to do all of that. So we really enjoy working with the mesh for this. Okay, and the last thing that I really would like to bring up here on this slide is safety. Besides money, and really probably even more so than money, safety is a huge deal for us. Nobody wants to go out there and not come home. Nobody wants to have a friend that doesn't come home, any of that. So what we've done is we've worked with a few other companies with our kinetic mesh to offer solutions that can be life-saving. Some of the most common applications that we see is video monitoring. With intelligence now, we're able to tell if there's somebody coming out on your location that should not be out there, if they've got any identification, or with facial recognition, we can actually tell who's out there. So we actually don't even need to go back and look at the video in some situations. We could just tell that isn't an operator. They're allowed to be out there. Or it's not an operator, we can alarm, we can do different things to let the company know that person's not supposed to be out there. Of course, we can also use those cameras for multiple things. In some situations, there's cameras on flares, and if we can tell that our flare should be operating, but the camera detects no flare, we know we're just gassing out, and could be a huge environmental issue, could be huge fines. So by using the camera technology, we can customize a solution that'll make your pad safe and let us operate those pads without ever having to even go out to them when conditions may not be safe. What you'll see at the very top is a FLIR camera. We've used that in conjunction with a few different things. We've got a vehicle-mounted system that we can drive around. We can use a FLIR camera. We've got other detectors that we can tell if there's leaks, and it's extremely accurate. But the other option there is with a drone. You'll see the drone over there. We can fly by facilities. We can automate things with Rajant, with the kinetic mesh. We are actually allowed to fly unmanned drones if there's never a drop in connection. There has to be a solid connection, without any drops. So we could build a network that will allow us to fly pipelines, check facilities, flares, tanks, whatever we would see. We've got an option for doing that unmanned and automated. So if we've had a blowout, it depends on how often you're checking your pipeline, but you could tell small leaks before they become a big issue. One of the other options that we see here is our Conspec. It is also, we've got fire detection systems, we've got leak detection systems, and with our kinetic mesh, we're allowed and able to put those on corners of pads, in spots where they need to be accessible to see that equipment, but they may not be accessible to a person. And again, with doing that, we're able to detect any leaks, any safety issues before somebody comes on the pad and is injured or killed. So this is some of the big pieces of what we do and why it's important to us. But again, without the kinetic mesh, we'd be hardwiring things. We'd be running a bunch of risk at anytime we trench, even if we do a one call. We all have heard or know of the stories that something was not marked properly. And I think just this weekend out in West Texas, we've had 3 separate explosions for situations like that. Either people not doing the one calls, or people not paying attention, or equipment that wasn't marked. So luckily, we've had a couple people injured, nobody killed. But again, that's not a good case, but it's not even the best case. We would ideally be able to avoid that completely using the kinetic mesh.
Hey, thanks, Scott. One of the things we want to talk about is, some of the things that some of the operators have done in adding real-time metering and telemetry in their operation. And these are just some of the things: improve well monitoring for sure, and to give them consistency and eliminate some of the risk. Accurate emission and inventory to track state and federal regulatory issues. One of the things I want to talk about, Scott, is what are the things are you seeing or getting requested by some of the clients that we have that maybe aren't listed here, that we've leveraged the infrastructure for?
Yeah, it's a good question, Al. I mean, we're constantly trying to evolve, and there's all kinds of things that come up that we're asked for. And that's one of the best things about the kinetic mesh is there's never really a hard no with what we can do. We've had to work around figuring out how the solution will actually work on occasion, but we've never had to turn a customer away because of that. Some of the examples are things that we had briefly touched on, but it's almost always something in our case that's safety related, automation related. New equipment, new technologies, and the evolution of it. The MQTT is becoming a bigger thing now. Edge servers are a thing now. With edge servers, things being done locally instead of coming back to a SCADA system, we need solid communications, because if that edge server can't make or can't communicate with the devices it's looking at, it can't make the decisions it needs. So that's again where this kinetic mesh and a really solid connection to every device is important.
When you're looking at a value proposition, these, we highlight just a couple. Beyond the simplicity of integrating the networks together, being able to get real-time data back. One of the other things that's a value add for a lot of the clients that are in the infrastructure network is we talked about the ability to do things other than the traditional telemetry and information coming back. One of the things that we've seen, Scott, is operators using the network for things like checking emails and doing push-to-talk radios and, like you said, the drone flyover. As we get going and we do more, do you see more use of some of the autonomy stuff in the field, like drones and things like that require higher bandwidth?
Yeah, we're seeing quite a bit nowadays with the drones and other technology. In particular, just recently, we've started working with a company that is utilizing drones for some of the wells that have been either temporarily abandoned or shut in for now. They're required in their particular state, they're required to turn in submissions at least once a month with the data from those wells. And as of right now, they have not had any automation. So we're able to actually put on a few small devices and then a kinetic mesh, and now we can fly over a drone over their field. And what used to take them at least a week to drive out to all of these sites, approximately 1,200 of them, and just get the data, handwrite it down, submit it in forms, we can now automate that process in a little over a day. Pilot takes up the drone, flies the field, collects the data. It's already there, automated, and they can submit the reports to the state. And it's also improved safety because they took it from doing it once a month to now they're able to do it either on a weekly basis or bi-weekly.
Okay. Yeah, so those things are really good and very well highlighted. One of the things we're going to get into is look at some of what we've done with other clients, and this is a particularly interesting case study where the client had a pre-existing network that kept getting dropping out as the wind knocked down antennas and moved them out of alignments. The client wanted to do more with their network. They wanted to run real-time diagnostics. They wanted to look at surface pump and pump data and do performance-based analytics. They wanted to do simulations on the field and on the rod pumps as they were working through it. This particular site is a site out in West Texas, about 750 wells, some tank batteries, and a few other things. Covers a little over 42 square miles. And the client was originally working with some narrowband units and with no fiber. The only connection was back in the home office. One of the things we've been able to do with that client is leverage the kinetic mesh and deploy it across the site to do not only well monitoring, performance monitoring, but actually it's become a safety issue like Scott was talking about, because now the people that are out in the field can actually call the office. They can actually communicate with the team in real time. And so it becomes an ability to make sure that, as they're out in the field and as they're working in very remote and isolated areas, that they have the infrastructure to be able to communicate with home, right? And be able to talk to the home office. The home office can call them. They can check emails. They can look at diagrams, permits, look at what else is going on, as well as the corporate guys being able to get that data back into the office. So that's just kind of a standard deployment. What I'd like to do now is we have some time for questions, and I turn it back over to Judy to see if there's any questions that we need to address.
Well, thanks, Al and Scott, for sharing all that information. I think now, if you haven't asked your question yet, is your chance to ask about how these advanced technologies can help you get better value on your project. So as a reminder, if you haven't already submitted a question, you can do it now. Just click on the Ask a Question area of the screen and type in your question and hit the Submit button. So the first thing that we had come in, Al, was a question about whether Rajant solutions work in non-line of sight areas.
Yeah, so that's a good question. So the way the Rajant solution works, you still have to have some minimal line of sight, but we don't require a straight physical clean line of sight. So we can put breadcrumbs scattered around a field, and as long as they can touch each other wirelessly, the connection is made. They'll go around a building. We were actually doing a prototype with a client yesterday, and there was a huge metal building in the way. So we actually moved a truck halfway into it, halfway between the building. So it was still, the building was still shielding some of it, but we were able to make a connection between and bridge that connection between the nodes. So it actually, just imagine a triangle with a big metal building in the middle, and that's so we can do some things architecturally so that the networks actually work together and can still mesh. In a traditional point-to-point, you've got to have straight, clear line of sight between the two buildings, a lot of times requiring tall towers and fairly clean Fresnel zone to make that happen. We've built a lot of technology into the radios to ensure that we can not only transmit better, transmit further, but listen better to low signals. One of the things that we pride ourselves on, is that we actually have a better ability to listen for those lower output signals. So like your radio, you're talking about your cell phone is probably a 1 dB gain type antenna, and the transmit power is pretty low. So we can build an infrastructure with those devices, whether it's a scanning gun or some kind of Oculus glasses that requires, to communicate. We can bridge that together in a mesh that works pretty well. And Scott and his team and our team have engineers that work with the end users to make that infrastructure work depending on the needs of the client. So each site is unique, each site is different, and the architecture is going to shift a little bit depending on their needs. But those are things that we can help enable that machine-to-machine connection and that reliability as we go forward.
We have a couple of questions about the breadcrumbs themselves. One of them is about the range of the breadcrumb, and the second one is whether it can be mounted on a UAV and what the power requirements would be.
So both are yes. So the range really depends on the topography of the area. I've seen in the configuration of the antennas. The antennas do matter a lot, and the configuration of the infrastructure. And I'll ask Scott to chime in on this after I'm done with my answer, just to clarify, because he actually does a lot more field installations than I do. So, really a lot depends on your free Fresnel zone and what you can do. I mean, it's hard to give a quantified answer. We've done reliable communications anywhere between 1 to 9 miles, but a lot of it depends on the configuration. UAVs is something that we pride ourselves on. We've done a lot of robotics, a lot of drone work. We actually have a product, the DX2, that is specifically designed for drone applications, very low wattage radios, less than 10 watts. And so we pride ourselves on the ability to mount our infrastructure on, remotely operated radios and facilities like that, whether you're doing Spot, the robot dog, to do security, or sniff test inside of a tank, to a drone flying autonomously to do infrared analysis of a tank or a field looking for leaks and that kind of stuff. Scott, what's been your experience on distance?
Yeah. So, like Al had mentioned, this is quite a bit of a loaded question, right? Because I could tell you I've got them going 15 or 20 miles, which is true. But I've also got sites that are 1.5 miles apart, and we've had to consider adding another node just to strengthen them. So it is very dependent on your terrain, other possible radios that are out in the field if you're around a bunch of other producers. But if I had to give a really general distance with just the very basic antennas, that we would put on a standard ES1 is I've almost never seen them go less than a mile. And in most situations, I can get them to easily go 2 miles and in some 3. That's just with the very basic antennas without looking at higher gains or anything like that. So I said, just safely, if you're doing it inside of a facility, I've had really good luck. A situation where we had another 900 megahertz radio that would not communicate, put in a couple different kinetic mesh ES1s, and the customer's now getting close to 200 meg per second. So they do work very well in that type of situation. Work really good around the noise, but just pure science. If you're putting it inside a metal building and you're trying to go 4 miles with a small antenna, it's probably not going to happen.
One of our other listeners asked a question about the points in the mesh. So with each point in the mesh being able to act as a node, are there any unique security considerations that he needs to be aware of?
So there's a lot of security built into the infrastructure. So we were born out of 9/11 and providing reliable communications to municipalities and the military. So we have a tremendous amount of effort put in to the security of the breadcrumbs. So we can do everything from SALSA to AES 256 encryption, as well as the military B suite encryption. All that comes in our commercial products. And we can do, SALSA is one of the lighter touch encryptions, all the way up to B suite per hop encryption. But at that point, you're eating up a lot of latency because you're re-encrypting the package at every hop. So we work with each client to make sure that we implement a strong, robust security model. We have yet to been able to not perform well in any of the customer's control system security testing. So we're not really concerned with being able to work with the client to make sure that they have a reliable and a secure environment. So security is just as critical as anything else.
I have another question here about offshore platforms. One of the listeners says that in a typical offshore platform, around 1,500 sensors are on, conveying parameters to the control room through communication wiring. And he's asking, is there any chance that you're propagating that this wiring communication can be done wireless to a control room?
We're actually doing work in offshore environments. We have a ATEX rated unit just for that type of environment that can go offshore. We've provided some of that infrastructure on a per deck basis, or actually in different areas to get that sensor data back. It's a little more complicated on a platform than it is onshore or even a chemical plant, just because of the density of the metal in the platform. So you end up adding probably a little more infrastructure than you would out in an open range, but it's very doable. We're doing a lot of projects with ship-to-shore type communication, where a terminal operator wants to have more visibility of the lightering operation and tankage operation. So there's a breadcrumb on the vessel, there's a breadcrumb on the shore side, and they're doing real-time high bandwidth communication between the vessels, so they can see and monitor the loading and offloading of the vessels, actually, and being able to talk to the employees on the tank more reliably than they have in the past. We're doing quite a bit of work with tankers out in the Gulf of Mexico, doing some other projects. And each platform as well is a little different. And we would need to take a look at, the number of levels, where the platform is. But the telemetry between the sensing data and bringing that back to the control center, either offshore or back on base, is not really an issue. we've done different projects with different partners to make that remote operation happen as well.
One of our listeners wants to understand. Oh, I'm sorry, Scott. Go ahead.
No, sorry, I didn't mean to cut in, but I was going to say if I could add to that just a little bit as well. I think everything that Al said is exactly right. I would like to point to a situation that we've had that's similar, not quite exact, but similar. I've got a customer that was not happy with their communications in the past and actually just didn't think they were reliable enough. So they've mandated that they are going to hardwire or fiber everything in their facilities and out on locations. They realized pretty quickly after doing that it was extremely time consuming and they needed that equipment up and operating quickly. So what they've done now is almost a hybrid, and they're doing radios, they're doing a kinetic mesh system, and they're actually getting their entire system talking first, and then they go back and put in their fiber or hardwire as needed to those devices. But one thing we didn't really touch on too much in the presentation today is that the kinetic mesh, it's not just a radio technology. We can actually mesh over any other copper wire. I mean, like any other connections, we can actually mesh those together. So what we saw in this application is we saw the mesh network be deployed. It was extremely reliable. They still felt that they needed that safety net of wiring devices, so they did that. And what we've seen is we've seen later on those connections at times can be cut, things happen to them, and with the mesh, it instantly can sense that and switch back over to radio communications. So I'm not familiar with this exact application on a platform, but there's not a reason you couldn't actually use both technologies for safety reasons. If it's equipment that you're deploying constantly and you need it up quickly, we can deploy the mesh network and have it be reliable. And then just if there is a safety need there, have it hardwired as well.
Thanks, Scott. So the next question is also about safety. This listener wants to know if you have intrinsically safe options.
So we do have C1D1, BCD, and F ATEX Zone 1 device available. It's been out for about probably 5 months. We're in the process of working on trying to figure out, how to make it smaller. But right now we have a unit. It's available on the website. You can see it, download the spec information. It's built around our ES1 platform. And it's rated for those types of environments.
Okay, well, we only have a couple minutes left, so I'll see if we have time for more than just this quick one. Does the Rajant kinetic mesh infrastructure work in level 2 or level 3 for bridging and routing?
So, good question. We support both. Natively, out of the box, it's level 2 networking. We can do level 3. Either way, it just depends on the client's infrastructure. We can do NATing, port forwarding. We have embedded whitelisting, blacklisting in the device. I'm not sure, talking to different clients, they seem to be a mix. Scott, how are you guys deploying, or is it, kind of one versus the other?
Yeah, it's definitely customer based. We're actually seeing both deployed somewhat equally. The layer 2, the best thing about that is we actually don't require IPs at that point. On an IPv4 anyways, we don't require any IPs on the radios, and it's basically agnostic to the equipment we're putting it in. Some of our larger companies that we're working with are severely limiting IP access in subnets. So by using the Rajant in that case, we're able to save them at least one IP versus a competitor. And sometimes some of the radios they're using need multiple IPs to do what they do. So it's a little bit of both. There's still some customers that are comfortable with wanting an IPv4 IP address on it, and using those in sort of a traditional network. So
yeah, so natively, we're one of the few companies that can actually do IPv6. So we have a lot of variety on how you architect your layer 2, layer 3 infrastructure. If you do it as a layer 2, you have the capability to eliminating some of the other devices that you currently use, so it simplifies the network installation.
Okay, well, thanks. That's all we have time for in terms of the questions for the live event. But remember, if your question hasn't been addressed, it will be answered via email. And as a reminder, the presentation will be available on demand within a week of the live event on the upstreamonline.com website. And when you get your email, you can feel free to forward that to others. Anybody else you think would get value out of the presentation, we'd be happy for you to share. So on behalf of Rajant and Winn-Marion, thank you for joining us today.